welcome to the next section of the course. Here we'll be simplifying some of these trigonometric identities that will be given. Right, so in this example, we've been asked to simplify this expression. Right, and we know that definition of cotan is 1 over tan, definition of sec is 1 over cos. So, simply put it, if we sine and write 1 over tan as cos over sine, so we'll have cos of theta divided by sine of theta. That's one way of writing cotan, because n of tan is sine over cos, inverse of sine over cos is 1 over sine, cos over sine, and n of sec is 1 over cos of theta. So we'll have these two cancel each other, and cos and sine will cancel each other out. Therefore, this identity actually is equal to 1. So I'll see you in the next example. Hi. So in this example, we are to simplify this expression. And looking at that, we can see that we have sec inside the bracket, and sec is 1 over cosine of theta, and we have cosec inside the bracket, which is 1 over sine of theta. Add these fractions with each other, and to add them we need a common denominator. Therefore, I'm going to just keep the sine cos outside the bracket as they are, and cross multiply these two with each other, and then we'll have sine theta multiplied by cos theta, which is exactly the same as the product outside of the bracket. So the denominator cancels the factor in front of the bracket, and what we simply left with is sine theta plus cosine of theta. So that's that expression as simple as possible. I'll see you in the next example. Right, in this example, we are to show that the identity is true. So we're going to start with the left side of the expression. Although it's larger, it's to simplify the left-hand side than to start with the right-hand side and try to manipulate that, because we don't quite know how it's going to turn out. So looking at the left-hand side, we can write cotan as cos of theta over sine of theta. We can write cosec as 1 over sine, and the denominator we can write as 1 over cos square plus cosec square is 1 over sine square of theta. So the product on the top of the fraction turns out to be cos on top of sine square. So just going to have cos theta over sine theta for the time being. The denominator has two fractions added together. So we can add those fractions by getting a common denominator. That means cross multiplying. The first numerator is going to have a sine square on it, and the second numerator is going to have cos square on it. And finally, I didn't keep the order as there is, so just going to put cos square at the front. So what we notice is that the sine square plus cos square is simply 1. Okay, so we can write this as actually keep cos theta here and sine theta, sine square here, and if I put a multiplication sign here and write the second, I'm gonna flip the denominator and write it Rice inverse because it was a division, just using mathematical rules here, and turning it upside down or inverting it. So now we can cancel away this sine square with this sine square, and on the numerator we have simply cos to the power of 3 because we are multiplying cos theta by another cos square theta. And that is the right hand side of the expression in the question. That's it for this question. So I'll see you in the next example. So in this example, we've been asked to solve the equation secant theta equals negative 2.5. And using our preliminary knowledge of what secant is 1 over cos theta. So to solve this equation, we are going to take the reciprocal of this fraction, or rather multiply both sides by cos and divide by 2.5. If I bring the work and write it on the right side here, that means that I will have 1 over negative 2.5 equal to cos theta. Now, once you divide 1 by negative 2.5, you'll have negative 0.4, and that is its absolute value is less than 1, so we can take the inverse cos or arc cos of negative 0.4, uh, sorry, 0.4 there, to get the answer for theta. And you should get a value if you put your calculator in degrees. What the question actually does tell us that we need to solve this equation in terms of degrees. So that's why I put my calculator in degrees, and the answer will come out to be 113.6. But is that the only answer? We should take care and consider the graph of cos over full range of 360 degrees. So any value that this point here is 90 degrees. So I know the graph the will cut um, at these 2 points. Let me just redraw the graph a little bit neater. Again, let's say this is the y-axis at 0, and this point here is 180 degrees, and this point is 360. So basic trigonometric will tell us that cos of theta is equals to cos of 360 minus that angle. So the complement of 113 is 360 minus 113.6, which will give us 246. So these two answers are what the final answer should be and what the examiner would look for. Okay, I'll see you in the next example. Right, so let's read and understand the next question. So in this question, we are to solve cotan of 2 theta equals to 0.6 within this range. So it implies that we are dealing with degrees here. And the first thing to do is to adjust our range of values, because in our question we have 2 theta. We need to double this range and go from 0 to 720 actually. And because in the final step of our work we will divide everything by 2. That's the reason we need to go ahead and expand our range. So now we can simply say 1 over tan of 2 theta is 0.6, and invert that, take the reciprocal to the other side and say 1 over 0.6 is what we need to take the inverse tan of, and then we take this 59, and we actually need to add another 180 degrees to it to figure out the second answer, because the tan graph will repeat itself every 180 degrees, and no matter what, if you had to figure out an answer less than zero, you would subtract 180 from this answer. But we simply added 180 to it to get 239, and we will actually go ahead and add another 180 to each of these values, because we need to extend our values all the way to any value that's less than 720. Therefore, we will have these four answers. Then, now is the time to divide everything by 2. So these four answers will be divided by 2, and theta will be 29, 120, 210, and 300 degrees. Right, so in the next example, we are asked to calculate the answer or to this expression 3 cosec theta over equals to 2 secant theta. And well, we'll check the coefficient of theta in this question is 1, so we don't have to extend the range here. We'll leave that alone. So what is cosecant of theta? Cosecant is 1 over tan, 1 over 1 over sine, my bad. So we'll actually leave the 3 on top of the fraction, and we write 3 over sine theta on the left, and on the right we can write 1 over 2 over cos of theta, because in this case we have some coefficients. So having written that, we know that in this kind of situation we can use and simplify the fact that sine divided by cos will be tan. So we multiply both sides by sine and divide by 2, so that we end up with this expression. We end up with tan of theta equal to 3 divided by 2, which is 1.5. Therefore, we can take inverse tan of 1.5 and add 180 degrees to it, and there is our final two answers. So happy practicing. I'll see you in the next section.